an internationally recognized expert in the fields of virology and immunology, and among the many committees he serves or has served on, he was a member of the Advisory Committee on Immunization Practices to the Centers for Disease Control and Prevention. He has published more than 150 papers in medical and scientific journals in the area of rotavirus-specific immune responses and vaccine safety, and has received numerous awards recognizing his accomplishments in these fields. The Vaccine Education Center at Children's Hospital of Philadelphia provides complete, up-to-date, and reliable information about vaccines. All of this to say, if you have a question about COVID or COVID vaccines, Dr. Offit is the person to ask, and we have him all to ourselves this evening. So please do not leave the webinar with an unanswered question. In the words of Francis Bacon, knowledge itself is power. And what better way to strengthen our scientific knowledge about the COVID pandemic than to listen to and ask questions of an expert in the field of vaccines? Now, I just recently learned that he was on MSNBC this morning at 10 o'clock, CNN at noon today, and now he's closing kind of sort of his day with NABT. So before I turn it over to Dr. Offit, I have two announcements. Number one, this session will be recorded and made public. And number two, closed captioning is available. So Dr. Offit, it is all yours.
Thank you very much. So what I'll do is I'll just talk for about 10 minutes and then hopefully answer the questions that you have. I think that we're getting there. The virus, this virus, SARS-CoV-2, came into the United States and started killing people at the beginning of March. And then what happened is you saw it would be 1,000 deaths a day, 2,000 deaths a day, 2,500 deaths a day. But as we hit February and March, as we hit May and April and May, you started to see the number of deaths come down. So rarely was it more than 1,000 deaths a day. Usually it was sort of 700, 800, very much like what it is now. And it stayed that way throughout last summer, even though we had a fully susceptible population, and even though we didn't have a vaccine, it really stayed that way last summer because this virus at its heart is a winter respiratory virus. So although it can spread obviously during the summer, it really takes off in colder, less humid climates. So then what happened is when it got to be November, December, it was 2,000 deaths a day, 3,000 deaths a day, 4,000 deaths a day, 4,500 deaths a day. And then as we got into sort of late February, March, it started to come down again. And it has stayed down. I mean, that we'll have, maybe we'll have tens of thousands of cases and hundreds of deaths, but it's come down and it's stayed down. I think this prediction of a spring surge is wrong. And we have two other things that work against this virus in addition to the weather. The first is vaccines. We have about a little less than 35% of the population is fully vaccinated. And closer to 45% is at least partially vaccinated. Plus, although you'll see that it'll say on CNN or MSNBC that 32 million people have been infected, those are just people who've been tested and found to be infected. When you do antibody surveillance study, you realize that number is probably off by a factor of 3. So it's probably closer to 90 to 100 million people who've been infected naturally, which also affords protection. So between natural infection and immunization, and those are overlapping groups because a number of people who were naturally infected have also been vaccinated, you're probably at about 50 or 55% population immunity right now. If you can get to about 80% population, which means we're going to have to immunize about another 80 to 100 million people, if we can do that by the end of the summer, fall, then when next winter comes, we won't see that surge in cases again as we saw last winter. I think there's two things that stand in the way of success here. And it's the second one that scares me more than the first. The first one is variants. So this is a bat coronavirus that sort of reared its head in Wuhan, China in November of 2019. And that virus has continued to adapt itself to growth in humans as it spreads in the human population. So it continues to make variants. The variants are often more contagious. So far, there are no variants that have clearly been defined as being more virulent, meaning more likely to cause severe disease. But as the variants, some of these variants are very similar to the original variant that came into this country, which had the fancy name D614G variant. That's really the variant against which all vaccines are made. Some of them are similar to that, like the B117 variant. The UK variant is actually very similar to the original variant. So immunization or natural infection will protect against that variant. But some of these variants are a little different, like the South African variant, the Brazilian variant, this New York variant, one of the California variants, are different enough so that even if you're immunized or naturally infected, while you're very well protected against severe or critical disease, you're not quite as well protected against mild or low moderate disease. So variance is one of the problems. The bigger problem, I think, is denialism, scientific denialism, which is to say there are people who simply want to close their eyes tightly and hope this all goes away and deny its existence. Deny its existence by refusing to wear masks, refusing to social distance. It's hard to watch. I mean, Texas Stadium, when they had their opening day, had 38,000 people there, mostly maskless. This was at the beginning of April. It's just unconscionable. I mean, I can understand bobblehead day and, you know, and t-shirt day. I just don't understand super spreader day, which is pretty much what that was at Texas Stadium. So denialism is part of it. And then it comes similarly with vaccines. I mean, you'll hear people say they just don't want to get a vaccine. It's just not for them because, you know, they're young and healthy and therefore they're not going to become seriously ill, which is, again, a lot of denialism. There are, of the children in this country, which is to say people less than 18 years of age, there's been 3.5 million cases, and there's been several hundred deaths. In addition, many thousands of children suffer a disease called multi-system inflammatory disease, which is basically inflammation of your blood vessels. This virus was falsely advertised when it came out of China. It was advertised as a winter respiratory virus like influenza that could cause severe and occasionally fatal pneumonia. It is far more than that. What this virus has the capacity of doing is it induces your own immune system to react against the endothelial cells that line blood vessels. Therefore, when we see children come into our hospital with so-called MIS-C, this multi-system inflammatory disease, they have heart involvement, liver involvement, kidney involvement, and I have no doubt that some of these children will suffer long-term problems, very similar to another multi-system inflammatory disease that we see in children called Kawasaki's. And not surprisingly, this is not limited to children. You never would have imagined it would have been limited to children, and it's not limited to children. There now has been recent description of something called MIS-A, which is a multi-system inflammatory disease of adults. And I think, at least in part, this may explain some of the so-called long haulers that have sort of more chronic and persistent symptoms, including involvement of the brain. So this is a scary virus. And to think that you are going to be one of the lucky ones who suffers a mild infection is to work with a lot of denialism. Last night, there was a woman on CNN who was great. Her name was Elizabeth Greenaway. She had been written up a couple of days before in the Washington Post, someone who was initially a vaccine skeptic. But one thing that she said last night that I just thought was great was she said, you know, it's not just about me. I mean, when I choose to not get a vaccine, it's affecting my child, it's affecting my parents or my grandparents. So she was the voice of society. It's not, when people talk about how this is a privacy issue, it's not. I mean, if I step on a rusty nail, go to the hospital, they clean out that wound, and then they offer me a tetanus vaccine and I refuse, that's a privacy issue. Because if I get tetanus, no one is going to catch tetanus from me. It's not a contagious disease. You get it when you step on a rusty nail or have a soil contaminated wound. But that's not true here. When you're saying you don't want to get a vaccine, what you're saying is that you think it is your right to catch and transmit a potentially fatal infection, remembering that there are hundreds of thousands of people in this country who can't be vaccinated. They can't be vaccinated because they're getting a chemotherapy for their cancers or biologicals for their chronic diseases or because they're too young at the moment. You know, you have an obligation to them as well. They depend on living in the herd, if you will, in order to be protected. So that's my message. My message is get a vaccine. I'm sure all of you have because you're science teachers, but not everyone has. So in any case, I'm just going to stop there and then take whatever questions you have before I turn it over to Charlotte. Oh, wait, I'm supposed to look at this. Okay, so Q&A. Okay, so this from an anonymous attendee. We keep hearing that the spike antigen-based anti-SARS-CoV-2 vaccines were developed at unprecedented speeds. However, it seems like there were already anti-spike vaccines developed for related coronavirus. So how does the vaccine development compare to the exceptionally rapid anti-Asian influenza vaccine done by Maurice Hillman in the 1950s? So Well, so although there were 4 strains of human coronavirus, there were never vaccines developed against them. But the anonymous attendee is correct in saying that when SARS-1 raised its head in 2002, or MERS raised its head in 2012, that there were preclinical studies and some early clinical studies on those vaccines. And so there was a little bit of a head start, but those viruses were very different in that they really didn't cause much asymptomatic infection. So when they caused infection, it was usually moderate to severe, so you knew who was infected. So you could basically put a moat around those people who were infected and then isolate them, and so stop the spread of the virus much easily. Most of the spread in this country and in this world is from asymptomatic people, so you don't know who's shedding virus. So that's why that was harder. In terms of the speed, and I'll get to the speed of making this vaccine, but when Dr. Hilleman made his vaccine, the Asian influenza vaccine in 1957, there still had been, about a decade's worth of experience making flu vaccines. So he at least had an idea of how to make it, grow it up in eggs, purify it, kill it with a chemical. So he knew at least the mechanism by which one could do that. Here, the reason this vaccine was developed so quickly was money. I mean, there was the so-called operation, the unfortunately named Operation Warp Speed, was a $24 billion effort by the government, basically, to take the risk out of it for pharmaceutical companies. So normally, you go phase 1, phase 2, phase 3, preclinical studies in experimental animals, then phase 1, which is basically dose ranging studies, make sure you have the right dose. Phase 2, you have the right dose, make sure you get consistent immunogenicity. Phase 3, you do a prospective placebo-controlled efficacy trial. What the government did was they said, look, we'll pay for the phase 3 trials, and we will mass produce these vaccines while you're doing that trial. So even though you may find that the vaccine that you're making, it doesn't work or isn't safe in these phase 3 trials, we don't care. We're going to mass produce the vaccine, and even if it doesn't work or is unsafe, we'll just throw away millions of doses. That never happens, and that's really what was the speed here. One thing that comes up that I get asked a lot, and also becomes part of the news in the last couple of days, is we now know that Pfizer is going to be submitting for licensure of their vaccine as compared to just approval through emergency use authorization. And so that question was asked today, actually, on television, what's the difference? I'll tell you what isn't the difference. What isn't the difference is the size of the studies. I mean, the 30,000 person trial of Moderna, the 44,000 person trial of Pfizer, the 44,000 person trial of the J&J vaccine, those are the size of any typical pediatric or adult vaccine. Similarly, the safety follow-up, which is 2 months after the last dose, the FDA insists on 2 months of safety follow-up after the last dose, is also typical of any vaccine trial, because for the most part, all of the serious adverse events that occur after vaccines occur within 6 weeks. So that's good. I mean, it may be so rare that you don't pick it up till it's millions of people, but if it occurs within 6 weeks. As you saw with really the blood clotting associated with Johnson & Johnson vaccine, a very, very rare phenomenon. Roughly 1 to 1.9 per million people. That's not going to be picked up in a 10,000 or 20,000 or 30,000 person trial. So the only real difference is length of follow-up for efficacy. So when the FDA licensed or approved these products through emergency use authorization, I'm actually on the FDA's vaccine advisory committee. What we could say is that these vaccines were effective for a few months, but we couldn't say it was effective for 6 months or a year or 2 years. When Pfizer is going to now submit for their licensure, as will Moderna, I think what you're going to find is that they'll have 6 months of data or 8 months of data, and that is going to be good enough, I think, to get a license. So that's really the only difference. Functionally, it's really more psychological difference, because I think what will happen is, I think when people see it's a licensed product, I think that's going to make it much easier for the private sector to mandate vaccines. I think that'll be the big difference between licensure versus EUA approval. It's an unfortunate phrase, emergency use authorization, because when people hear that, they think hydroxychloroquine, which was approved in the last administration for the treatment of COVID-19, and it didn't work. It didn't work to treat the disease. It didn't work to prevent the disease. It should never have been approved without at least some preliminary data. And people see that happening with hydroxychloroquine, and they think, well, maybe the same thing's happening with vaccines, where corners are being cut, safety guidelines are being ignored, none of which is true. So it's really the way these vaccines are being approved is really very much similar to what would be for a licensed product. I mean, I've sat on the committee where we have approved vaccines for licensed products versus EUA, and there's really no difference. Okay. If a fully vaccinated person contracts the disease, What are the chances of developing long-term COVID? Okay, so vaccines aren't 100% effective. They're 90 to 95% effective for the mRNA vaccines in terms of preventing moderate to severe disease. They're about 85% effective for the J&J vaccine. So if you're vaccinated and then you get, let's say, significant infection, is it possible then that you could go on to develop more long-term symptoms? I think the answer is yes. And so you wonder if when someone gets vaccinated and then they develop asymptomatic infection or mildly symptomatic infection, that's good. I think that tells you that the burden of illness for them was small. I think the chances then that they're going to have long-term illness is very, very small. So it really depends on the nature, I think, of the illness after vaccination. How do you talk to this from Desi Demova? How do you talk to vaccine deniers? Yeah, so I guess I divide this into two groups. The first group I would call a vaccine skeptic. And if you look at sort of the polls that were conducted in September, 30% of people in September said they would definitely get a vaccine. By December, when the data became more available, that 30% became 50%. And then in just more recently, it's about 70% of people say they would definitely get a vaccine. So those to me are the skeptics, meaning they weren't sure. They wanted to see data. Fair enough. I think you should be skeptical of anything you put into your body, including vaccines. And so they are convincible by data. They are convincible by logic and reason and data. So that's good. The deniers are different. I mean, the deniers are at their heart conspiracy theorists. They don't trust the government. They don't trust the pharmaceutical industry. They don't trust the medical community. So forget it. I mean, I just don't think there is any convincing them. I mean, as Neil deGrasse Tyson famously said, if someone reaches a conclusion without using logic or reason, then logic or reason isn't going to talk them out of it. So I think that's true here. That's all you have on your side is data, logic, and reason. And if that doesn't work, then you're stuck. And then what do you do? I mean, what do you do if we get to a point in this country where such a significant percentage of the population are just vaccine deniers that are choosing not to vaccinate? Then what do you do? And I think what you do is you mandate vaccines. I mean, we're now discussing that at our hospital. There are other hospitals that have already mandated vaccines. It's already happening in private industry. There's nothing in the law that says you can't mandate a vaccine that is approved under emergency use authorization. Although I think when it's licensed, it'll be, I think, easier for some people. But that's what you do. I mean, in a better world, in a more logical world, a reasonable world, you wouldn't have to do this. People would look at the data, they'd be convinced by the data, but we don't live in that world. There are people who simply deny scientific truths. They claim that vaccines cause autism. They claim that evolution and creationism are equally valid hypotheses, even though that's not true. So I just think we're living at a time when people declare their own truths, and sadly, that also includes scientific truths. So that's how I see that. Okay, so the next question, let me see one. Okay, so they're actually both, the next two questions are similar in terms of vaccines for children. So Pfizer just submitted for, and will no doubt within the next few days, receive emergency use authorization to vaccinate children with their mRNA vaccine down to 12 years of age. That was based on a 2,300 child trial, a prospective placebo-controlled 2,300 child trial. Half got the vaccine, half got the placebo. They found that those children that got the vaccine had an excellent immune response. They found that the vaccine was safe. There were 18 cases of COVID in that trial, all in the placebo group. So I'm sure the parents whose children were in the vaccine group were happy about that, and I'm sure the parents whose children were in the placebo group weren't. I mean, that's a pretty significant rate of infection. It tells you that this is 18 cases in a group of 1,000. It's about 1 in 50. So it's a 2%, a little less than 2% rate of getting infected. So when people say, don't worry about children, they don't get infected, that's not true. And that was just proven actually in this study. So, parents are now about to have a choice about whether to vaccinate their children. And I've heard parents say they wanted larger trials. So instead of maybe doing a 2,300 child trial, we could do a 23,000 child trial. And that way it won't be 18 cases of disease in the placebo group. It'll be 180 cases in the placebo group. And so is that what we want? I mean, the question is never, when do you know everything? You never know everything. The question is, when do you know enough? Do you know enough to say, given that you have now experience with this vaccine in people over 16 years of age, for say the Pfizer vaccine, where about 200 million doses of this vaccine has been administered safely. I mean, do you feel comfortable enough now down to 12 years of age? Yes, it should be the answer. Were my children between 12 and 15, I would give them the vaccine without hesitation because they are at risk of getting infected. And I guess we're all shaped by our experiences. Mine is that I have been on service 3 of the last 6 weeks at Children's Hospital Philadelphia, and we see a lot of disease there. I mean, we have a COVID ward. We have, you know, most of the kids we see are Miss C, and it's pretty frightening to watch. So that's what motivated me. Okay, so the next question here is, can you speak to the possible future applications of mRNA vaccines? Yeah, that's a good question. I mean, this has been an amazing story. I would have never predicted this and didn't predict this. You have this virus, this SARS-CoV-2, which has already had a number of surprising clinical and pathological observations that no one would have predicted, which you then meet with the technology, mRNA, for which we have no commercial experience. I mean, what could possibly go wrong? I kept waiting for the other shoe to drop on this technology because the virus was unusual. We hadn't really understood the virus. We did what we always do with vaccines, which is try and induce antibodies against the surface protein to prevent the virus from binding. But this technology was new. And, you know, I just assumed there would be something that we would find. I mean, in the original studies, the Pfizer-Moderna trial, there were about 8 cases of Bell's palsy in the vaccine group. You know, Bell's palsy is a one-sided facial paralysis, and only 1 in the placebo group. And I thought that was going to be it, but it wasn't. I mean, as now, you know, 200 million doses have been administered, there is no greater instance of Bell's palsy in a vaccinated or unvaccinated group. And I kept waiting for that thing to happen. It hasn't happened yet. So that's been amazing. So now we have this amazing platform. Now, my understanding is that the data that we have so far, looking at, for example, this technology for human immunodeficiency virus, or a universal flu vaccine, or a better tuberculosis vaccine, or a malaria vaccine, have not been nearly as phenomenal as what we've seen for for SARS-CoV-2. But obviously, that's just in the early stages of research. But remember, this vaccine technology, mRNA technology, has been around for almost 20 years. I mean, the seminal paper was published in 2008, but you know, there was a lot of research obviously before that. So it hasn't translated to other vaccines yet, but we'll see. I certainly am optimistic that that could be true. I think one thing that's really been cool is that we now have a lot of experience with the mRNA technology in pregnant women. So, and we know that it's safe. I mean, there's just a paper that recently came out of the CDC by Tom Shimabukuro and coworkers, looking at thousands of women who received this vaccine during pregnancy, and then those women were followed throughout their pregnancy up until the birth of their child, and hundreds of children have been born, and then compared that to women who were pregnant who didn't receive the vaccine to see whether there were any differences in sort of maternal outcome or fetal outcome, and there were none. So that's encouraging, because there are other vaccines we could make for pregnancy, like a Group B strep vaccine or meningococcal vaccine. Or a respiratory syncytial virus vaccine. So I think that this has now told you that there's a safe platform in pregnant women. So I think that's one of the good things that's happened with this. Okay. So I'm going to be talking now for the next 30 minutes, I guess, answering questions. So don't worry about the fact that I was up at 4:30 this morning. You know, I'm on it, so don't panic. Okay, they are now discussing vaccine mixing. The first dose is Pfizer with the second dose is Moderna, or vice versa. Will it be as effective to cross vaccines if they recognize different parts of the spike protein? So for the most part, these vaccines induce antibodies against the receptor binding domain and the N-terminal domain of the spike protein. They aren't the same molecule. They're not exactly the same, but they're pretty close. So the CDC recommendation is under extenuating circumstances. You can give the Pfizer vaccine after Moderna or vice versa. And they can be given up to 6 weeks after that first dose. And we will generate more data here in this, and we'll see. But it's extenuating circumstances being where you got the first dose of Pfizer, you can't get that Pfizer vaccine anymore, but you can get the Moderna vaccine or vice versa. So I think we'll learn as we go. We'll also learn whether these vectored vaccines can boost in a better way after the mRNA vaccines or vice versa. But those data haven't really been generated fully yet. Okay, do I think that the future COVID vaccines will be annual shots, and could they be combined with a flu shot? So I'm going to predict, and you should never predict things about this virus because you're always going to be wrong. And I see that you are recording this, which is, probably always dangerous because now I'm about to be wrong in a recorded manner. But I don't think we're going to need a yearly booster for this vaccine. The reason I say that, because I don't think we're going to need a yearly booster because immunity fades. Obviously, if a variant emerges that is completely resistant to immunity induced by natural infection or immunization, then you're going to see a second generation of vaccine. But that's not really a booster vaccine. By booster, what I'm saying is that you're giving the same vaccines that we're giving a third or fourth time. I know we're preparing for that. But if you look at the data for either of the mRNA vaccines or the Johnson & Johnson vaccine, which has been given obviously much less among the three, that you actually appear to induce fairly high frequencies of memory B and T cells. That usually presages more longer lived protection, meaning a few years, maybe not decades, but at least a few years of protection. So I'm going to predict, although immunity may fade to some extent, meaning that you don't have 90% protection in year 2, maybe it's 80% and then 70% in year 3. That's still excellent. And I think that it would be even better than that against severe critical disease. So I am going to predict that we are not going to need boosters, assuming a completely resistant variant doesn't arise, that you would not need a yearly booster. That said, if we do need a yearly booster, then the question is a perfect one, because it would then I think we really do need to do concomitant use studies with the influenza vaccine to make sure that those vaccines can be given at the same time safely and effectively. But I think that'll be the only concomitant use studies that are going to be done with these vaccines in the near future. Okay. Excuse me, this is CNN. 1 second. This is Paul Offit. I'm good. I'm doing a webinar right now. So what's up? Yes. Yeah, I prefer not to do it that late, if that's okay. Okay. All right. Okay, sorry. Yeah, I want to take a rain check. Okay, thanks. All right, bye-bye. Okay, just turn down CNN. Okay, because this is more important. All right, let's go. As an educator, our school system saw a large increase in non-identified severe respiratory infections early September, October in 2019, which doctors only identified as severe respiratory virus. Do you think COVID was around much earlier than they said? I think that's certainly possible, and that is knowable. I think we need to go back and look at serologies from, for example, these kinds of kids and see whether the virus did enter this country earlier. It would not be surprising at all that it did that. I mean, China was not a good friend and neighbor here. They weren't. What they did, we shouldn't have had to have depended on a whistleblower in Wuhan to tell us that there was a virus that was spreading. We should have known much earlier than that. And so do I think that there was travel outside of China before we were alerted to the fact that this virus was spreading? Yes. Do I think that that travel could have involved the United States? Yes. So do I think this virus had entered the country earlier? Yes. But we didn't really have the testing in hand then to know that, because we hadn't really identified the virus yet or sequenced the virus, which didn't happen really until January of 2020. So we didn't know then about how to test for that. But I think we will go back and we will answer that question. And I suspect you may well be right that that's true. Okay, so with one of 13 children having food allergies and reported cases of anaphylaxis in individuals who received the mRNA vaccines, is there any more information about the component of the vaccine that is causing anaphylaxis? Many parents of children with food allergies are concerned that their child may react to the mRNA vaccine. So regarding anaphylaxis, which occurs, it depends on whether it's the Moderna or Pfizer vaccine, but it's between roughly 2.5 to 5 cases per million vaccinees, which is a little more than the background rate for vaccines, which is more like 1 per million. So this is 2.5 to like 5.2 per million. So it's a little more than that. It is probably the polyethylene glycol component of the lipid nanoparticle, which has nothing to do with food allergies. So there's not, food allergies does not put you at risk for getting allergies to this. Nonetheless, if you've had a severe a reaction, an anaphylactic reaction to either a food or medicine, you're still recommended to receive this vaccine, but you are asked to stay in the area where you got the vaccine for at least 30 minutes, so that in case you require epinephrine. But as yet, there's no evident predisposing component other than a known history of polyethylene glycol allergies, which is rare. So no, the food allergies really is irrelevant to this story. So to what extent did experiences treating SARS-CoV-1 virus, I assume you mean responsible for the Asian pandemic 20 years ago, inform current efforts to respond to the current pandemic? I wished it had instructed us more. What we needed to put in place right after that first pandemic potential virus raised its head was an international surveillance system, and an international system where we collaborate to make sure that we can quickly isolate a virus, identify the sequence, make vaccines, test vaccines, get personal protective equipment in place, make incubators, get oxygen tanks ready. I mean, get ready for what could be a massive event, which is what we're seeing. Because remember, this is a worldwide problem. I mean, this is not an American problem. And to think of that we can just take care of ourselves and not worry about it, not true. You are only as strong as the weakest countries out there. I mean, think about the fact that we give every year a polio virus vaccine to children in this country, even though we have not had a case of polio in the United States, natural polio in the United States, since the 1970s. We do that because polio still exists in the world. It's still in Pakistan and Afghanistan. And really, it's only endemic in those two countries, yet still we vaccinate our children every year with polio vaccine. Now think about this virus. I mean, there's 194 countries out there. I think 100 of those countries have never given a single dose of vaccine. We're going to be living with this virus for a while. We are going to have to make sure that we are protected against this virus for a while, which may well mean booster doses 2, 3, 4, 5 years from now. But I do think this virus is a virus we're going to be living with. So I don't think we did learn. I hope we've learned here, because this has at the very least gotten our attention. I mean, it's brought us economically to our knees. All right. It is difficult for us to counter the anti-vaccination movement, which had its start even before Andrew Wakefield. How is the best way for us to educate the public against strange rhetoric? Right. Well, first of all, you're absolutely right. I mean, the birth of the anti-vaccine movement was associated with the birth of the first vaccine, which was the smallpox vaccine. And the Anti-Vaccination League is what it was called. Was born in the early 1800s. Jenner's vaccine, the smallpox vaccine, was in 1796. So we've been dealing with this for a couple of centuries. And it's hard. We live in an open society. We live in a society where you have a right to free speech, and you can say things that are absolutely wrong, and you can get it out there on social media, and you can scare people, and you can cause them to make bad decisions based on bad information. You can do that. You're allowed to do that, and you can try. I mean, I was asked on Kate Baldwin's show the other day about the fertility issue. Because it's out there that women of childbearing age, some are scared to get this vaccine because they think it's going to affect fertility. And that's just wrong. And the reason it's wrong is that there was a letter that was written by 2 researchers to the European Medicines Association in December of 2020, claiming that the SARS-CoV-2 spike protein genome shared several homologous sequences with a placental protein called syncytin-1, which is necessary for the development of a healthy placenta. So the thinking was that if you're making an immune response to SARS-CoV-2 spike protein, you also will be inadvertently making an immune response to syncytin-1. Well, that's not right. There is no molecular mimicry. The sequence sharing is minor and inconsequential. It's like saying you and I both have the same social security number because both those social security numbers contain the number 6. So it was a false premise. And then you have data that argue against it. During the Pfizer and Moderna trials, there were 36 women that became pregnant during this prospective placebo-controlled trial. And the thinking is that the vaccine was be inducing antibodies against syncytin-1, then all of those pregnancies should have occurred in the placebo group. They didn't. They occurred equally in both groups. Also, the natural infection also induces antibodies to SARS-CoV-2 spike protein. We've had about 100 million people who've been naturally infected with this virus. The birth rate has only increased, and although that's a multifactorial thing, I think, again, if this was devastating fertility, it certainly doesn't seem to have done that. So it's all wrong, and so now you know. So now you know that it's all wrong, and you can get it out there, and as I tried to do on Kate Bowen show the other day, but you know, it's just hard. It's easy to scare people. It's just hard to unscare them. It's hard to unring the bell, or as Jonathan Swift says, falsehood flies and the truth comes limping after. And that's true. It's hard. It's the fight we fight. But I mean, as science teachers, science educators, science communicators, that's the fight we fight. And so you just keep fighting. And you fight on social media. I mean, there are a lot of people who really get on these anti-vaccine blogs and try to really get good information out there and counter those blogs, and good for them. Because I think that's really where the fight is being fought now. I mean, I would say 20 years ago when Andrew Wakefield sort of burst onto the scene, I think the anti-vaccine people were much more fetid. I mean, you had anti-vaccine people who were voting members on the FDA's Vaccine Advisory Committee. You had anti-vaccine people who were voting members on the Advisory Committee for Immunization Practices. You had Congress that would actually have congressional sessions where they would have anti-vaccine people testify. That's very rare now. I mean, Ron Johnson, who's a Republican from Wisconsin, did that recently, and much to the chagrin of everybody. I mean, he was sort of shouted down for that, as well as a number of other things. But so you don't really see that anymore. So the fight now, the anti-vaccine people now are more on social media, and that's where that fight is occurring. But it's hard, and so all we can do is the best we can do. I mean, it is amazing to me though that they're allowed to do that. I mean, I don't know if you saw Tucker Carlson the other day had this sort of rant about how, you know, thousands of people have died from COVID-19 vaccines because the deaths have been reported to VAERS. So, you know, which is like assuming that every death that's reported to VAERS is a causal phenomenon associated with the vaccine, which isn't true. The only way to know that is to have a control group, and when control groups are done through the Vaccine Safety Data Link, and these deaths are investigated, they're not caused by a vaccine. There's always another reason for the death. So it's just wholly irresponsible. So I don't understand why he's allowed to do that. I don't. When he gets on TV and he has this rant, scaring people away from vaccines, thus putting them at risk, putting those with whom they come in contact with at risk, why is not that the same thing as shouting fire in a crowded movie theater? I understand that he's not characterized as a news program. He's an opinion program, but still, I don't see what the difference is. So it's the downside of free speech. All right. See what that was a similar question. Okay, so what are your thoughts about a COVID passport to allow access for vaccinated people to travel and also go to public venues? All for it. I guess I'd like a better word than passport, maybe vaccine certification or something. Certainly other countries do that. I mean, Israel does that. If you want to go to a bar or restaurant in Israel, you got to have your little iPhone, you know, with the barcode that says now you can go to the bar or restaurant you want to go to. I think that is already happening. I mean, you've seen more than 40 colleges and universities said if you want on-site learning, be vaccinated. Otherwise, you still have to stay off-site. And bars and restaurants, some bars and restaurants are doing that here. And now the Los Angeles Dodgers have a vaccinated-only section. The Atlanta Braves now said if you wanted to get into tonight's Braves game, where they play the Philadelphia Phillies, you have to be vaccinated. You were offered a vaccine before going in. So, because they want a full house, but they want everybody to get a vaccine. So, I think we're getting there. I do think we'll get there. But that's certainly the anti-vaccine people. If you ask the anti-vaccine people, what do you want? What would make you stop doing this? I think they pretty much would all say the same thing, which is don't make us get a vaccine. Don't make vaccines mandatory. Make it optional. Which would be fine for the tetanus vaccine, because if you want to kill yourself from tetanus, fine. But it's not fine for a contagious disease, because then you're making decisions for other people, and that is not your right. I'm sorry. I don't think it is your right as an American citizen to catch and transmit a potentially fatal infection. I mean, this is a country that was founded on individual rights and freedoms, and so we're very quick to claim freedoms, even freedoms that we don't have, like that one. Okay, so this one is, if I got a J&J vaccine originally, will I be able to get an mRNA vaccine booster? No data yet. So I think those data will be generated. But, you know, one dose of J&J's vaccine is able to induce cellular immunity, induces high titers of virus-specific neutralizing antibodies, has excellent protection against moderate to severe disease. So I'm not sure you need a booster. But if it comes to be that there is a booster later on, I think by the time that happens, you will have data to know whether or not that would be the way to go. So this is from someone else. I am a microbiologist and community college professor. How can I help encourage people to get the vaccine? I have given Q&A sessions to colleagues and students. Should I do the same at local libraries, churches, and community groups? Yes, absolutely. I mean, you know, Tip O'Neill said all politics is local. I think all science education is local too. I think, you know, what John Udell, who's the head of virus research at NIH, years ago said what he wanted was an army of citizen scientists out there educating the public in any venue possible. I mean, elementary schools, colleges, universities, you know, school, social gatherings, church gatherings, synagogue gatherings, whatever, you know, to just get out there and do that. No venue is too small. I think that that's true. I mean, I remember when my daughter was in the 6th grade, her teacher, science teacher, asked me to come give a talk to her 6th grade class about vaccines. It was without question the most harrowing talk I've ever given in my life. You know, and I was on the Colbert Report a couple of times, but this was more harrowing than that. Because, you know, the 19 of the students seemed to be enjoying it, but one of them just had that look on her face that was, don't embarrass me in front of my friends. And I did make it through that, but it was nerve-wracking. But I think you should do it anyway. Just out of curiosity, what is your opinion of the longer spacing between 2 shots in Canada? I mean, you never, it's the initial thinking was let's get as much first dose out there as we can, because at least that offers partial protection. With vaccines that are 2-dose vaccines, you do need that second dose. I mean, the mRNA vaccines, you need that second dose because it's then and only then that you get the kind of cellular immunity that would predict long-term protection. So you never need to start the over again, but I think getting it according to the way the studies were initially done would be the preference. History celebrates the role vaccines played in overcoming incredibly destructive pathogens such as polio and smallpox. Will COVID eventually join that list, or is it the new flu in the sense that a seasonal resurgence will become normal and expected? I would be surprised if we eliminated this virus. I would. I mean, it's a mucosal pathogen. Viremia, meaning virus spread into the bloodstream, is not part of pathogenesis. You can eliminate diseases, and we have eliminated diseases where virus spread in the bloodstream is part of pathogenesis. Smallpox, polio, have that, measles. I mean, we eliminated measles in the United States, rubella. I mean, those are all have a very similar pathogenesis. These mucosal viruses, which really replicate for the most part at the site of entry, it's harder to do that. And so I think we will be living with this virus for the rest of my life. I plan to live another 25 years before I am captured and killed by the anti-vaccine people. But so I think that's what I would say. But I think we can control it. I mean, when there was an article in the New York Times that said, you know, we'll never get to herd immunity. If you define herd immunity as significantly reducing the spread of this virus, we can do that. I think that's already happening in Israel. I think that's already happening in the United Kingdom, where they're at like 65% immunization. So I think we can do that. And when they say 60 to 65% immunization, that's immunization. Plus you get to add on natural infection to that, even though obviously there's overlap between those two groups. So I really do think we have to get to 80% is my feeling about this. So what is my opinion on the risk benefits of gain of function research of viruses? I guess I do have an opinion on this. I don't have complete faith in humankind. I think when you do gain of, so for those of you who don't understand, so gain of function studies is you do experiments that allow a virus to do something it wouldn't normally do. So for example, rabies is transmitted by the bite of an animal that's infected with rabies. If you want to do a gain of functional rabies vaccine, you could, and rabies is a terrible disease. I mean, the answer to the question, what virus has the highest mortality rate? It's rabies. I mean, if you have not been vaccinated against rabies and you have signs and symptoms of rabies, you're dead. There's only 5 people who have ever survived rabies after they were infected and were not previously vaccinated. 5. So it's a universally fatal infection. So you could take that virus and make it spread by the respiratory route. I mean, that would be a gain of function study, a potentially disastrous gain of function study. There are things that are learned from gain of function studies, but I just worry that the price paid and that we would have to trust our fellow man and fellow scientists to do the right thing, and to know that these viruses would never get into the hands of a rogue nation or group that means to do other people harm. I don't trust that. So I guess I'm not for gain of function studies. I think there's a group called Physicians for Social Responsibility that did take a stand against this gain of function study. Okay, what evidence is there that the increased rates of blood clotting from J&J and AstraZeneca are due to the antigen or the adenovirus? Are there other adenovirus-based vaccines that have caused blood clots at similar rates? So the AstraZeneca vaccine does cause thrombotic thrombocytopenia. So thrombus, clot, and lowering the platelet count, which seems like two contradictory things, right? Because when you have a lower platelet count, usually bleeding is the problem. The reason isn't clear. The pathogen and J&J vaccine also, between 1 to 1.9 per million people will get a severe blood clot. Now, remember, this like such as cerebral venous sinus thrombosis. But remember, the virus does that too. The virus has about 5 to 6 per million people will have cerebral venous sinus thrombosis. So you're actually more likely to get that severe blood clot if you're infected than if you're vaccinated, which is a point that the CDC made much better, I think, when they had their second meeting. So the question is why? Certainly the pathogenesis is the same, which is that you make antibodies to platelet factor 4, which when activated then causes platelet aggregation. There is a similar phenomenon called heparin-induced thrombocytopenia, which happens when heparin binds to platelet factor 4. Your body then sees platelet factor 4 as foreign and makes an antibody response to it. Presumably the same thing is happening here. The leading hypothesis right now is that when you give a lot of virus, and you're giving a lot of virus, you're giving like 50 billion virus particles, whether it's the J&J vaccine or AstraZeneca vaccine, that there is some liberation of adenoviral DNA, which then binds anionically to platelet factor 4. It's just a hypothesis, but then causing that platelet factor 4 to be seen as foreign. So we'll see. We'll see how that plays out. There was previous experience with the Johnson & Johnson vaccine because that was the Ebola vaccine. That replication defective adenovirus 26 was the Ebola vaccine in West Africa, but it was given to fewer than 200,000 people. So you may not have seen this very, very rare event that's occurring, in 1 in 250,000 to 1 to 2 per million people. So that's probably why you never saw it. What do I see as the big scientific questions that come out of this pandemic? I think that the big ones are, probably most importantly, what is the mechanism? What is the pathogenesis of these multi-system inflammatory disease that's now seen in children and adults? Because that matters. I mean, if it comes to be, for example, that and I don't think this is it, but if it comes to be that the reason that these children get this vasculitis is because there is molecular mimicry between SARS-CoV-2 spike protein and something on endothelial cells, and I don't think that's it. That matters then in terms of boosting those children later on with a SARS-CoV-2 vaccine. I think rather it's either a super antigen that induces this sort of this cytokine storm essentially. But we'll see. So I think that's one big thing. What's the pathogenesis of this multi-system inflammatory disease, these vasculitides that are seen with this virus? I think it is important to know what exactly is the cause of thrombotic thrombocytopenia. I mean, we know not to treat it with heparin, but we don't really have the pathogenesis down yet. I think I would also like to know how to treat children with MIS-C. What we do is we give them steroids or IVIG or both. And what's frustrating for me in this is when Kawasaki's, which is another multi-system inflammatory disease, raised its head in the 1970s, very quickly the right kinds of studies were done looking at aspirin, steroids, IVIG to see which among those was best or what combination was best. And we knew that early on. We don't really know that yet. I mean, there really aren't studies that are being done. The rheumatologists and cardiologists are giving one or both or neither without doing a lot of studies on this. We need that information. And so hopefully that is generated out of this as well. So to me, those are two, I guess, of the big ones. So what should an ideal surveillance program for detecting emergent pathogens look like? How close are we and what next steps do you think need to be taken? I think there should be an international team of scientists that are, when alerted by any country that is starting to see an unusual outbreak of a virus or bacteria that they hadn't seen before, quickly go in there and identify what's going on. And this has to be an international effort that's organized by groups like the World Health Organization, but who basically have no money. But I think there has to be an international collaboration among the countries that do have money to put together something that protects us all. You know, we are responsible for our neighbor, and I think that right now, what really should happen is that these companies should give up their intellectual property and should help manufacturing plants be built around the world that can mass produce these vaccines. It's not easy. The Biden administration just in the last few days had said they want to remove intellectual property, which is great, but that's really just step one. I mean, as the saying goes, the hardest part of making vaccines is making vaccines. And it's not easy to mass produce lipid nanoparticles. Not easy at all. And I think you saw what happened with Emergent Biosolutions, where that company was shut down by the FDA when it was trying to help Johnson & Johnson make its vaccine. It's not easy to make vaccines because they're biologicals. They're not like small molecule drugs like amoxicillin, where you can easily characterize there's 50 milligrams in this tablet, there's 50 milligrams in the tablet in the next batch. These are biological, so the process becomes the product. And it's not easy to do it. So I think that has to happen. Because again, we are only as strong as the weakest countries out there. This is a global problem, and there needs to be a global solution. And that global solution needs to be mass production of these vaccines in all the research and all the sites where they can be produced. So this one is, how do the concentration or frequencies of memory B and T cells produced by the COVID vaccines compare with other vaccines? Well, I mean, it's just a paper by Rafi Ahmed. There's been papers by Shane Crotty that it looks promising. That's why I'm predicting that we'll have more long-lived protection. So the next question is, would a third dose of Moderna increase the efficiency? Why do we stop at 2? Well, you get excellent protection at 2. I mean, you have 95% protection after 2 doses against all manner of disease, against all for all age groups, against all comorbidities. I think there's, you're good at 2. So it may be that we'll need to boost down the road, but for right now, we don't have that information. So the last question, I'm going to make this my last question, then turn it over to Charlotte. How severe was the political pressure on the FDA and CDC? The FDA was under a lot of pressure to release hydroxychloroquine, and they did it, and they shouldn't have. They shouldn't have. There was no data showing that it either worked to treat or prevent the disease. I think that the previous administration was looking for a magic medicine. They thought they would sell this as a magic medicine. They bought almost 30 million doses of this drug to hand out there. They wanted all of this to magically go away, and it didn't work that way. That was unsettling. That never came before our committee because we're vaccines, not drugs, but that was unsettling. And the CDC obviously was under a lot of pressure too. I mean, you saw when Nancy Messonnier got on national television, when she realized very early on that this was going to be a major problem in this country and said so, she was censured and recently just left the CDC. So sadly, so I think both were under a lot of pressure. But I think the FDA in the end stood up. I think Stephen Hahn in the end stood up, or at least Stephen Hahn was put in a position where he had no choice but to stand up, but he stood up and said, we were doing 2 months of safety testing after the last dose. We are not going to curtail that because, and by doing that, that pushed the vaccines into December, which was to say after November 3rd, after election. And there was pressure to do it sooner. There was an op-ed actually written in October about fear of an October surprise by the Trump administration. So people were all worried about this. So there was pressure, but I think the FDA in the end certainly stood up for vaccines, and CDC always stands up for vaccines, but they were under certainly a lot of pressure. So I'm going to stop right there and thank you for your attention. Sorry for that phone call in the middle there, but I was supposed to be on CNN later, so I just wanted to cancel that out. They wanted me to be on at 8. Let me turn it over to Charlotte, but first by introducing her. Let me just get this thing here. So Charlotte Moser is the actual head of the Vaccine Education Center at Children's Hospital of Philadelphia. She lets me hang around, which I've always appreciated, but she is the driving force behind our center. And our center is remarkable, I think, in the amount of educational materials that we provide, both in video form and print form and movie form and animation form. And I think we have, certainly Charlotte's going to tell you, I think, about how many visits we have to our website, and I think how influential our website has been, and she is the reason for that. And we also have to celebrate the life and work of Maurice Hilleman, we have an essay contest that she's also going to talk about, but you guys are lucky because this is an amazing woman. Charlotte.
Thank you. And I wanted to thank Julie and Jackie and the whole NABT team for supporting us this month. Tonight's event was really the first of several events throughout the month of May to support and celebrate our 2021 Maurice Hilleman Essay Contest. In addition to tonight's presentation by Dr. Offit, you can watch the Hilleman film for free during the next several weeks. You can also get a discount if you want to purchase the film. And 2 weeks from tonight, we have the pleasure of Don Mitchell, who's the director of the Hilleman film, who will be talking about art and science and the importance of storytelling in science, as well as offering some thoughts on a sneak peek at the project he's working on now, which is another really cool science-based, vaccine-based public health story that you'll want to hear about. So hopefully you'll clear your calendar for 2 weeks from tonight. In case you haven't heard, the Hilleman Film Essay Contest, this is our 3rd year, and it's for 6th to 12th graders. And each year we change the theme so that students can write about a little bit something different. And we thought this year it would be really appropriate to talk about creativity. So the theme for students to write about this year is, how did Dr. Hilleman's accomplishments demonstrate the importance of creativity in science? And we encourage students to learn about Dr. Hilleman. He was an amazing scientist who helped to create more than half of the vaccines that are currently routinely given to children. And his work alone is estimated to save 8 million lives every year. Many of you may have seen the film or heard us talk about it before, especially at some of the conferences. But if you've not seen it, it's definitely something worth taking the time to watch in the coming weeks. We'll have 3 national winners for the essay contest. The students will each receive $1,000 and will be honored in a virtual celebration this fall. Dr. Offit will host that celebration, so the students will get to not only meet Dr. Offit, but we have a really special secret surprise keynote address scheduled. So that's an important part of the project prize that nobody knows who it's going to be yet. We're also going to have a premiere of a short film about creativity and science that Don will be putting together, and it'll be the world premiere that night or that afternoon. And as I mentioned, Don will be speaking here in the next couple of weeks. Teachers also are going to get to win. If your student is one of the winners, and there's a place on the essay entry form where they list their teacher, you'll be invited to the virtual celebration as well. You'll be allowed to bring your current students, so it'll be your students for next fall. You'll get a signed book of Pandora's Lab, 7 Stories of Science Gone Wrong, written by Dr. Offit. And also we're really thankful to NABT because they're offering a free 1-year membership of NABT for those 3 teacher winners. So if you want to learn more, check out either hillemanfilm.com or our classroom program is vaccinemakers.org if you've not checked out that website. Unfortunately, our Vaccine Makers Project Outreach Coordinator, Alice Gongleski, couldn't be with us tonight because she had a previous engagement. But Alice is awesome. If you have questions when you're on that site, just send in an email and she gets right back to you. She can support you with questions about the essay contest or about any of our lessons. We have free animations, free lesson plans, and we're always excited to hear new ideas and such. So please feel free to start a conversation with us. And so with that, I'll turn it back over to Julie. And thank you everyone again for spending Friday with us.
Thank you. So this concludes our webinar. So on behalf of NABT and the Vaccine Makers Project, I would like to thank Charlotte Moser for sharing information about the Hilleman Essay Contest, to Dr. Offit for empowering us as educators by strengthening our knowledge about COVID, and for making me laugh when he turned down CNN during our webinar, Dr. Offit, may you never get apprehended by the anti-vaxxers as you spread sound scientific knowledge. And last but not least, thank you to our webinar attendees for spending your Friday evening with us. Take care, be safe, and get vaccinated.